Hey, what's going on, everybody? Today's homework assignment 35. Our objective, I can add and subtract numbers in scientific notation. So we're going to go over two different strategies you can use. We're going to go over my not so favorite strategy and my favorite strategy. So the strategy that I'm like iffy about and the one that I like a lot. Okay, but they're both helpful in different circumstances. So here they are. So strategy number one, which is not my favorite strategy, but still helpful sometimes, and I'll show you when it is. Step one, convert the number to standard form or numbers to standard form. Step two, add or subtract the values. I'm going to actually change this to numbers right now. Step two, add or subtract the values. Step three, convert the numbers back to scientific notation if you are asked to express your answer in scientific notation. And I could add this part on to the last part that I have on the next page. And let's take a look here. So strategy two, I like this strategy. Rewrite the values so that they both have the same exponents, and I'll show what that means. Step two, add or subtract coefficients. Step three, rewrite with the answer in correct scientific notation, and I'll include my little parentheses area here. Okay. So we will go through both of these strategies, all right, just to help us out here. So we'll go through both strategies. All right. So strategy one. All right, strategy one is going to involve us writing our numbers in standard form first and then performing our operation. So let's go ahead and do that. So I have 5.45 times 10 to the third power. Let's get it to standard form, which would be 5.45. I'm going to move over 1, 2, 3 places. Therefore, the new number is 5,450. All right, 3.12. I'm going to move it over 1, 2, 3, 4 places. My new number will be 31,200. Add these two values together. So I'm going to line up my values. So 5, I'll write my little one on top. Doesn't make a difference. 5,450 and 00213. And you can use a calculator to help you out with your addition if you need it. So we have 0, 5, 6, 6, 3. So 36,650. Written in scientific notation. Take my decimal point, I'll move it over 1, 2, 3, 4 places. 3.665 times 10 to the fourth power. All right, so again, this is strategy one, turning the standard notation and then going and doing the addition. All right, let's just do strategy one again with the second problem. All right, so let's get them both to standard form. One is already in standard form, so very nice for us. So we have 2.78. 1, 2, 3, 4, 5, which will be 278,000 minus, and we line up our decimal places, 46,500. All right, let's do some subtraction. So we will have 0, 0. Let's borrow 5, 1, 3, 2. So 231,500. Let's get it to scientific notation. 1, 2, 3, 4, 5. We will have 2.315 times 10 to the fifth power. All right, so that was that first strategy, and it works whenever we have smaller exponents or numbers already in standard form. It works nicely for us. Okay. Let's see strategy numero dos. So in this strategy, I'm going to try and get both of these numbers to have the same exponents. So let's say I want to get them both to be 5. Let's make them both 5. So I'm going to take my coefficient 1.7. And if I want to take two exponents away from two values away from my exponent, then if I'm making my exponent smaller, I'm going to make my coefficient larger. So I'm going to move my coefficient over 1, 2 places. So there's my new decimal point. And when I did that, my exponent decreased by 2. So now I will have 170 times 10 to the 5th power. Remember what we said, that's not in correct scientific notation, but we can make it work for right now. We'll get it back to correct scientific notation at the end. So let's go ahead and let's add these two values. We could add these coefficients now. So I have 170 plus 6.25. So here's my decimal point, 0, 0. I'll have 5, 2, 6, 7, 1. All right, I'm going to attach that power of 10 that I had before. So it should be 176.25 times 10 to the 5th. And now let's get it back to correct scientific notation. I want to move my decimal over 2 places. My coefficient gets smaller by 2 decimal points, so my exponent gets larger by a value of 2. Therefore, I will have 1.7625 times 10 to the 7th power. Again, so you can see why one strategy might be a little easier than the other. I like this strategy because I feel like it's a little less messy. You may like the other strategy, and if you like the other strategy, you want to use it all the time, you go for it. All right, last problem that we're going to see. I'm going to use my strategy again. This time I want to turn my 9 into an 11. So I'll have 2.84. Actually, I won't even worry about that just yet. I want to get this 9 and turn it into an 11. So I'll rewrite my value here. So 5.4 times 10 to the 9th. So if I want to make my exponent larger, that means I have to make my coefficient smaller. So I'll move my decimal point over 1, 2 places. And with that, I can add 2 to my exponent. So I'll have 0.054 times 10 to the 11th power. And I'm subtracting that, 2.84 times 10 to the 11th power. All right, let's subtract the coefficients. 2.84 minus 0.054. Always make sure you line up your decimal points correctly. Sure, I'll borrow from here for now. 10 minus is 6. Borrow from here. 13, 8, 7, 2. Bring down my decimal point, and look at that. It's already in nice form for us. So we'll have 2.786 times 10 to the, what exponent did I use? 11th power. And there you go. Strategy number 1, strategy number 2. Find the one that works for you, or use both like I like to do sometimes. But then again, this last one is my favorite strategy. All right? Check out those practice problems. Use these models to help you out. Use the steps to help you out. I'll see you tomorrow in class.